Good evening, everyone, and thank you for joining in this last part of this cohort. We are having the projects which we're going to be doing together in this class. So welcome again, everyone. Thank you very much for joining. So far we have looked at different aspects of R from the very beginning aspect where we looked at the entire interface of R Studio. We also looked at the elementary data structures and the complex ones at that. We considered various types of visualization. We looked at a couple of packages and how to learn R from packages, installing and loading packages in the R Studio. We went further to consider some special data manipulations using tidyr and the rest, and a couple of other packages. We examined modeling using the empty cars data as an example. So today we are wrapping up with a project. We're going to be using a student data, example data for our project. Okay, so let's dive in. All right, so thank you very much for joining up to now. So before we go into the code, I'm going to give a brief information about the data that we're using. So to do that, let me take you down to the particular information about the data itself. Okay, just one moment, please. I'll show you that right now. PDF file. Okay, so if you can see my screen, this data is data from a Portuguese school describing two particular schools actually in this data. So here we have information about Gabriel Pereira School with their Portuguese schools, and then Mocinho da Silveira School. So we have information about their sex, male and female, this is binary information about their age, the range from 15 to 22. We have information about their address, binary, and urban area or rural area. Talking about where they stay, possibly where the family stay. And then we have the family size. Is it less than 3? Is it greater than 3? Okay. We have their parents' cohabitation status, binary. That means they are living together, or T for living together, and then A for living apart. I need us to know this so that when you start looking at the data, you'll understand how to work around the data. Like I said, this project is very important. It gives you an idea of how to manipulate your data when you see them. Models education. This is purely numeric. At the same time, it's representing more like a factor. You will understand what factor means as we go ahead. 0 means none. 1 means primary education up to 4th grade, and then 2 means 5th grade to 9th grade. 3 means secondary education, and 4 means a form of higher education. The same thing with the father's education throughout that category as well. We also have the mother's job, nominal. So this is a nominal meaning that, okay, so you have teacher, health, care related, civil service, and so on and so forth. As you can see, please, if you're coming in, just mute your mic. Thank you. So we have a reason, the reason to choose this school. Yeah, the particular reason to choose a school. Is it close to the home? Is this for the school's reputation, cost preference, or others? Okay, so we have guardian. Who is the guardian? Student guardian. Is it the father, mother, or others? Travel time to school. Will this affect what we are trying to do? Less than 15 minutes. 2 is for 15 to 30 minutes. 3 is for 30 minutes, and then for 1 hour and above. Okay, 3 is for 30 minutes to 1 hour, and then 4 represents greater than 1 hour. The study time of the child, weekly study time, 1 is for less than 2 hours. Study time between 2 to 5 hours is represented by 2. A child that studies from 5 to 10 hours is represented by 3. And then greater than 10 hours is represented by 4. Failures, number of past failures. Okay, so schools up, extra educational support. Does it exist? Yes or no? Families up, families educational support. Yes or no? Paid, extra paid classes within the course subjects. Yes or no? Activities, extracurricular activities for the child. Yes or no? And so on and so forth. Okay, is there free time? So you can read about this later when you get the document. Now, what is this? Okay, and then towards the downside, you see the first period grade, more like the first term grade, second term grade, and then the final grade of the child. So what are we trying to do with all this information that we have? We want to be able to model what the final grade of the child would be. Okay. Now, these are everything that surrounds the child's life in school, with respect to the parents, with respect to number of time present in school, with respect to whether the child is involved in a romantic relationship in school or not, with respect to whether the child has internet access at home or not, with respect to the educational background of the parents themselves and everything. We want to see which of these factors, how many of these factors affect the final grade. Of course, you would agree with me that this grade 1 and grade 2, they will correlate very well with the final grade. But can we find any other factor here that will help us explain the final grade, such that if that factor is tweaked a little or more, the final grade of the child will be improved? Okay, so this is what we're here to look at. So the attempt is to model, to be able to predict the final grade of the child given X, Y, Z information. Okay, let's remember that. Okay, so I'll just go back to our R now to show us. I believe, yes, what we are working on. This is what we're working on. One moment, please. Okay, so to start this, you spin up your R Studio. There's a particular package you might want to install and spin up, which is called Tidyverse. Yeah, some of the functions may exist in other packages, but just try and spin this up. You install it first, and afterwards you will this should come first. After installing, then you just need to load the library, and then we'll start working. Okay, so the particular file that we are using, which you will have access to, so I need you to just pay attention in this class, not to bother about you doing it. Just ensure you understand. I'll provide you with the complete code to execute this on your own, and also have the same result. Okay, so the folder where your data is, this is the data we are using, student-math.csv. I'll send this to you later. The folder where it is in your system, go and copy the path of the folder. Okay, the complete path of the folder. Copy. When you copy it here, this slash sign you are seeing is going to be like this. It's going to be in this form. You can work with it like this in R. So you come to the top here and use this find and replace button. So when you do use find and replace button, you'll type in what you want to find, this here, and then here you type in what you are replacing, and then you replace all. Once you do that, everything will be replaced and you have bit like this. In short, make sure you put it in quote. So this set WD, what it does is that it sets a working directory such that you can pick up anything within that working directory directly, the way I've picked it here. Okay, so having set your working directory, the next thing you want to do, let's do this. So the next thing you want to do is to load the data. So we are creating a student.dat object here where we will load the data. All right, see the syntax I have used to load it. We are loading a CSV data. Ensure you put a CSV extension here together with the name. Here you are saying that the data has header. If you are not to be putting this, that means you are going to give it a header yourself. So indicating this means that take the first line as the header. And then, so when you load this, no error, that's fine. Okay, so to be sure that all is well, all is fine, you can just come here and do kind of a summary. Like I said, what summary does is that summary gives us a descriptive statistics of your data generally. Of course, some descriptive statistics you'll be getting may not make sense because you are seeing in some places you are seeing 1, 2, 3. They may not really represent numbers. In any case, it will return a descriptive statistic. So majority of the values we have in this data, they are not really to be interpreted as numbers directly. As you will see later, we are going to convert them to what we call factors. Some of the factors are to have a kind of a nominal form. Nominal means that you are expected to know that there's a difference between, there is a level. Okay, let me use the word level now. So there are levels in it. So you're expected to know that 3 is more than 1, 4 is more than 3. All right. In some other case, when it is not leveled or nominal, in that case, they are just merely factors. Okay. So you have nominal factors that have levels, and then you have just ordinary factors that are not leveled. You will see that later. All right. So remember, we are looking at this data and we are trying to let's see the head of the data. Take note of the codes I'm using. So what this will do for us is that it's going to give us the first 5 data, the first 5 entries in the data. So let's examine that. So this is the data. It's a very long one, 30 something or so fields, if I'm not wrong. So this is the beginning of each school, the type of schools. Remember, there are just 2 schools. So this is showing us the first 6 elements in the data for all the columns. Okay, as you can see, I told you all of this already. Mother's education, father's education, mother's job, father's job. We already saw the meaning of all this. Okay, and yeah, so you see reputation, what's that? Okay, paid reputation or something, activities, internet, romantic relationship or not, family relationship, all of this. In the end, what we are trying to model is this last one here. Okay, so this last one will now be our Y. This is what we are trying to model. It will be our Y. So now we are going to isolate We're going to isolate this G3, which is our Y, from the rest. So we are going to isolate. Please mute yourself, I beg of you. If you're just coming in, kindly mute yourself. We would really appreciate that. Okay, thank you very much for that. All right, let's go back to what we're having. So there are a total of 33 columns. So the last column there is our Y. Okay, so this is how you do that. Remember when we were doing it, dissecting initially, how to, enter a data frame and slice it. So in this case, we are targeting the last column. This comma here means all the rows, then the last column. Okay, that's our Y. So we have locked Y here. So we created a new object here. It's a vector in this case, but it's a single data, vector. And then here we have a data frame because it has 32 different columns here. So this will be our X. The rest will be our X. Okay, let's see if our X is without G3. So you can see G3 is out of it. So we have our X without G3. Okay, now we cannot just model directly like you saw the other time when we did modeling. Okay, when we, let's say, model 2, and then we use linear model, and then we say our Y first, right? Y, and then we use this sign, and then we say X, then we say data, and then we say students dot that. Okay, we can't just do this directly. No, that's not acceptable. The reason is because we have not fine-tuned our data. The component of our data needs a lot of reworking, okay, for it to be ready for modeling. So let's go into it and start working. So what we are going to be doing, so we're going to be picking data one by one. Let's see the structure of the data, str of our data. Some of them are numeric already. In fact, they may all be numeric by default. Student data. As you can see here, they are all showing int. But we know what we are looking for. Okay, so we don't need this for anything. I mean, our linear regression is going to be working with numbers and factors only. All right. So character will not work in linear regression. So we need to convert. We need to tell the model what this will mean in a slightly numeric form. Okay. So that is what this is going to be helping us to do. So we are picking the columns one after the other now. Okay. So how are we doing that? So we're picking this column school, and we are saying we are factoring it. Okay, factoring it. What are the levels of values inside already? We have two values, GP and MS. Okay, we are changing the way it should appear in the data to 0 and 1. GP will become 0, MS will become 1. Okay, that is what we are doing here. And the reason is because there is no way we can use GP and MS in our data. Okay, but when we represent this same thing with 0 and 1, it makes more sense. So the factor will now be 0 and 1. That's what the refactoring is doing here. For the sex, we have two levels, female and male. It will now be 0 and 1. You can also use 1 and 2 if you like. All right. The address, we have rural and urban by using 0 and 1. Hope this is making sense. The family size, we have two greater than 3 and less than 3. We're also using 0 and 1. Don't worry, the 0 and 1 are specific for each of the classes. So don't think that 0 and 1 in one column will clash with the other. No, they are recognized for each of the classes. for each of the columns. So we have parent status A and T, 0 and 1. So in other places where you have, so check it out. So this is mother's education. The levels are already 0, 1, 2, 3, 4. But we are, relabeling it as the same value, of course. Okay. Yes, because this 0, 1, 2, 3, 4 might be showing there as numeric. So we are factoring it that, okay, this is not actually numbers that you can plus or add or multiply. These are factors. So we are giving it the same values, but factoring it in this case. So you have father's education, you have mother's job. Now it's making sense here. Mother's job at home, health service, teachers and others. So we are labeling this as 0, 1, 2, 3. So father's job, same thing. And so we're getting to another aspect now. Reasons, cause, home, reputation, others. So now this is what we do until, so we do this for almost all of them. So there are, okay, so let me show you these aspects. Family relation, or what is the FAMREL for? Quality of family relationship. Okay, quality of family relationship. 1 is very bad, and then up to 5, which is excellent. So family relationship here, 1, 2, 3, 4, 5. I'm looking at this. So family relationship, 1 is very bad, and then 5 is excellent. Okay. So of course you have it 1, 2, 3, 4, but this ordered true means that it gets better as you go higher. Okay. So we also have a similar situation with free time. Let me check out the free time thing. So free time after school. Okay, 1 very low, up to 5 very high. Okay, so that one also is ordered true. Do they go out? They go out. The same thing, these ones are ordered. All the ones down here, they are ordered. Okay, meaning that you can actually relate that 1 is less, 5 is more. Okay, so we'll do that up to here. We are not doing anything factoring to G1 and G2 because they are numeric in themselves. Also, if you look at here, we didn't do anything to age as well because age is numeric. So what we are working on is supposed to see the age and see it as a number indeed. So we are not factoring age. There is no sense in trying to factor age. Hope that makes sense. So we are going to run all of these parts, okay, one after the other. Sex, address, family size, parent status, job, father's job, reason, guardian, internet, schools. So we are running for all of them. Okay, so after we are done with this, we may want to see STR again. But this time it's going to be STR of X. Let's see, how is our data seen now? Okay, as you can see here, the levels have changed. It's no longer the way it was before. So you see that there are factors now. Age is still numeric. School is now factor. All right, 2 levels. Address are now factors. 2, 3 levels, 5 levels. And then when you come to travel time, these ones are still numeric. Failures are still numeric. Okay, so we left those as numeric. Schools up, these ones are now factors. Now look at the ordered factors. See the way arrow takes them. Ordered factors. You see? Less than. Are you seeing that? Good. I like this. So the absences, these ones too are taken as numbers. up to the G1 and the G2. At this stage, if there are any questions, let's respond to the questions. Thank you.
Sir. Yes, sir. I am. Eh? Yes. Hello, can you hear me, sir? Come on. Ah.
Papa T,
Hello.
sorry, I
Yes,
was
sir.
muted. I was muted. I didn't know I was muted. Go ahead, sir.
Okay. Sorry, I don't know if it's my internet or something that went on. I lost you from the time that we got our values that we were saying that the statistics was not generic, so we changed it from the generic to the ones that we actually needed from where we defined the data. That was why I lost you. On that one where we put, I think that was line 5, 5.
This is where we started. Are you there, sir? Are you there, sir? All right, Mr. Dio, unmute yourself and speak.
Yeah, good evening, sir. Thank you for the good job. Sorry, I want you to please kindly explain the aspect of set work directory, set WD, that the point at which we import our data, where you say we can find and replace. That aspect, I didn't get it. To import our data generally. So just the two line.
I'll do that right now. I'll share my entire screen and show you that. Okay?
Okay, sir. Thank you.
Good. So everyone pay attention to this aspect of that. So I have a directory here that I use for my this R training. So like you can just click on the top here. If you click out, if you click on the top here, it's going to show this. So if this is the directory, the folder where you are working, just do that. Copy this. I mean, that's where you have put your data. This is the student data I'm using here. Okay, you have access to this data. Any folder where you put it, you're going to have it like this. Then you come here and copy the directory. The good thing about this is that if you are writing out a result, you just need to write it. You know, it's going to come to this directory because you have made it your default working directory. Is that okay? So you copy this thing here. You come to your R, and then you type set WD, which means set my working directory I'm working on. Do your shift and then have this double quote here. Inside it, drop it. Now you see that the slash is, you know, like this from up down. All right, top left to, you know, bottom right. So you come here, you click on this sign beside source on save. Just click on this sign here. I'm sure that is visible. I hope that is visible to you guys. So you come here. All right. Once you do this, you see something like this. So you click on the ones you don't want, the one that is there already that you want to change. You come to replace the one you want. You see there are two. There is the forward slash, there's a backward slash. Okay, and then you click on replace all. When you do that, it's going to replace all of them. You're done with this. So if you don't do that, it's going to give you an issue. All right, you won't be able to, R will not be able to read the first, is it backward slash now? You call that one. It's not going to read that. Okay, so that's what I wanted to show you. I hope that makes sense. I hope that makes sense. All right, Mr. Diogun, I'm talking to you. Please confirm if you were able to get that. Okay, thank you. Okay, so good. Papa T has disconnected. I hope he joins back. In any case, so far, so we have been able to, please, for those who have data they need to manipulate, please take note of this. Of course, this might not be the very sophisticated examples. Whatever data you're working with, of course, you have to either bring it in as an Excel or CSV. If it is not in that table format, if there are special kind of data, of course, there are tools also to help you in working with them. All right. So we have been able to convert this data to factors, which is pretty good. So the next thing we are going to do now that everything is in the way they should be, the next thing we are going to do is we are going to model. All right. Because of our time, I'm going to copy the part of the code here. Okay, so as you can see, we are writing our model. We are calling it model 1. The reason is because we will be running several iterations until we get the best model, all right, or the optimal model that would require not as much variables like we have now. Currently, we're going to be modeling all the data. All right. Remember, your Y here is your G3, which you had, which you passed here, because that is what you are modeling. You want to model the final results of every child's grade to all the factors that affect the child, that contribute to the child's, in school. So here, this is how you write it. This is a simple. So this is a multiple linear regression in this case, because you are modeling different columns, you are modeling different data to, what's it called now? I'm modeling different data to our Y. Okay? Okay. So, so before we do this, we are going to create another data. We'll call that data S1, which will be equivalent. Okay, just a moment. We have our X, because here we're using X1 data here. So if this Y gives us this, so we need our Y in it. So we are going to have one to be equal to our X. Okay, yeah, let's do this way. Our X, and then we'll have X dollar Y. Good. Will now be equal to our Y. Good. That's what I wanted to achieve. So as it is, if we do head of our S1, so what we are doing here is that we combined the two data, okay? So that when we are in this model here, we are saying the column that has the value of Y, model that with all of them. But at this point, we are saying in this data S1, you are going to see Y and all other ones, okay? Of course, we could have called this G3. We could have called this G3, but it's okay. Let's leave it at Y. So let's see what this gives us. As you can see, we are all set. Okay. Remember, they now have, of course, this thing might still be showing M job, I mean, at home, teacher, and the rest, but we have converted it internally to what the real, to the factor that we want it to be. Okay, so we are having our first model, which is the Y against all of this. What would that give us? So we just run that model now. Please, if you are coming in, I beg of you, mute yourself. That is very important, please, so that we can have quietness. Okay, so we just run our first model. So to be able to see the everything about the model, we are going to use the summary model one. Summary model one. Let's examine the model. This is what the model gives us. Oh my God, how many? So when we run this, we'll get a few stuff about the model. The minimum first quartile, we don't need some of this. So for each of the factors, for each of the variables that we model, x1 up to x32. All right. Firstly, we have an intercept. This is the intercept. The intercept is 2.789. Of course, despite being a multiple linear regression, there is still an intercept. So we are modeling dimensions up to 32 dimensions, but still there is an intercept because it's a linear regression. So you now begin to see each of these, their corresponding values. Coefficient of the school as a variable, an independent variable. This is the coefficient. It's showing us that the type of school has a positive correlation, but very low. So just 0.36 explaining. The sex of the child has nothing, to do with the final result. The age of the child also has nothing to do. Address of the child is negatively correlated. The family size is negatively correlated. Mother's education, father's education has nothing to do. The mother's job, father's job has nothing to do. Very negatively correlated. Age has some level of significance, but in the end, it has a negative correlation. So we may not consider it much. As you can see, down. Activities here has some significance value. You'll see how we determine this later on. So all of these are the coefficients of each of the variables. But when you begin to get towards down here, you see that, the absences, whether a child is in class or not, has some level of correlation to whether the child passes well or not. The value, what the child gets in their first term, which is this G1, has some level of significance. So this star and the dot, it's measuring how significant a particular variable is. Okay, a particular independent variable is. So please take note of this. So we are going to now, going further, you see that now, so the R squared, which will be what we normally use, is telling us 85.81% explainability. So R squared is normally called coefficient of determination. It's trying to tell us how good the model is, essentially. Okay, so in this case, it has to be called multiple R squared because this is a multiple linear regression. Okay, our p-value, of course, is over significant. Okay, so but these are too much to include in your model. Imagine writing the equation for this in your software. This is too much. So you need to bring it down such that you'll be using less factors. At the same time, you'll still be having your level of R squared explainability. Okay, so how do we do that? So we're going to go so in our second iteration, we are going to model the fairly significant values, G2, G1, absence, We can take this also. This, we'll take this. We'll take this. Okay. You might be wondering that these things are not, these particular things are not as much as this, but why do we have it much like this? So those places where we call them factors, so what the model did was to take them one by one. Okay, it has a way of doing it internally, so it took them one by one. So if you said factor is 0, 1, 2, 3, okay, 0, 1, 2, 3. So what it will do is that it will create a separate table of itself. Anywhere there is 0, for the one of 0, it will give it 1, 1, 1, 1. Any other thing that is not 0 will be 0. Okay, it comes to where the value is 1. Anywhere it is showing 1, it will give it 1, 1, 1, 1, 1. Wherever it is not 1, it will give it 0. That includes 0, 2, 3, 4. It will get to another, it will create another column where it is 2. Whatever is 2, it will give it 1, 1, 1, 1, 1. So it's going to create a binary value table for each of those factors. So in the end, for reason 1, 2, for reason 1, 2, 3, this is what it does for that, and so on and so forth. Okay, I hope that makes sense. All right, so this is the reason why you have bits as much as this. Okay, so romantic, we're taking this as well. So in the end, let's see what our model 2 will be. Okay, so let me get the code for model 2 to make it faster. Okay, so let's do for model 2. So for model 2, we are picking the age, which appeared, where is it? So the age here, which has some level of significance. There's a dot here. We never know if it will be significant eventually as we go on with the iteration. I think we also picked activity. Okay. Activities. Okay. We picked activities, family relation, absence. So those ones that appear to be a little bit significant, we have picked them. So we are rerunning the model. So let's say the version 2 of the model and we'll compare with version 1. I hope this is making sense. So version 2 of the model comes out. Let's see the summary of the version 2 of the model. Okay, so version 2 of the model comes out like this. We see the age, see activities, family relation, and all of this, and then we see absence, G1, G2. Now, how does this compare to the first one? What is our multiple R squared? 0.8359. Here is 0.85. Of course, there is a reduction, but if you see this, the adjusted R squared 0.83. You see, we are still doing well. So it's better to come up with this multiple R squared and these few variables. The meaning is that these variables you see here alone can explain up to 83% of G3. Okay, whereas all these 31 or 32 of them can explain 85%. If you go and look at the adjusted R squared, you almost say that, in fact, the fewer ones here are doing better than the 31 variables we have picked earlier. That makes sense? So, but we are going to go further to break this down. We are going to pick the more significant one. In this case, the ones that have this significant stuff here. So we are going with absence up to G2, and then we are going to family relation. All right, and let's see if age will also follow this time. Somebody's mic is on. Please kindly mute your mic. Okay, so let's take the third model. Let's make the third model and see what comes out of it. I want to believe so far so good. We are okay. So let's go with the third model. Model number 3. Model number 3. So from what we were able to pick from our results, for model number 3, we are going with age. We are dropping activities. We're going with age, family relation, and all of this. Now you see how we have drilled down to the more important factors. If we had not modeled all of them, we wouldn't have known that these are the major things that contribute to our G3, the final grade, which is Y in this case. Okay, it depends on what you are modeling at your own end. You may want to model diseases and all of that. So if it is linear regression you are using, of course, this is a straightforward thing for you. But if you are using other types of modeling like logistic regression, or you want to use higher level models, support vector machine, random forest, and the rest of them, there are also simple model lines for all those as well. So if we are moving with this, let's run model 3 this time around. Let's see the summary. Let's see the summary of this model. Let's see the summary of this model. Okay, so you see that we have 0.38344. What is the one for the initial one? 0.8344. The initial one was 8359. Okay, so just a little reduction. So we are still good. We want to minimize the variables that are contributing. At the same time, having a perfect, a near optimal model, a very optimal model. Okay, so at this stage now, you might want to think, why not just let it go? I mean, we are good, we are okay at this stage, all right? But the answer is no. There's something you may want to try. These two, this G1 and G2. Now, in linear regression, there is a rule you must follow in linear regression. No two variables within your, no two columns, among the things you are trying to use to model must be correlated. Okay, that means there should not be the name for that thing, for that condition, is that you must avoid multi-collinearity. Multi-collinearity, you must avoid it. It means that if any of these variables are correlating, all right, now what's the use of using the both of them? For example, as you will see now, G1 and G2 are highly correlated. I'm talking about if G1 and G2 are highly correlated, meaning they can explain themselves, why should you have it there? So at a point, you may want to test which of your variables have some level of correlation. Which of your variables have some level of correlation? But before we do that, we may let's try before we do that, let's try and remove some other factors. Okay, let's do another version of the model. There's another version of the model. We are going to be removing some other guys there. Okay, so we are removing the age. Okay, we're removing the age. Let's leave family relation and removing the age, because in this last thing that we did, the age, looking at this p-value here, so we can just let the age go. Let's leave the family relation and this absence. We're already seeing the most important variables here right now. So if we let the age out, it should still be something good for us to see. Yeah, we're still good, 0.83. We're still within the neighborhood of 0.83. Okay, but now we want to consider the correlation potential within our model. Okay, we want to consider the correlation within our model. So how do we do that? So let's look at it together. So we are going to carry out, a summary of model 4. because I'm going to copy in this. I'm going to be copying this code to you later. Okay, so here we are trying to do a correlation of the numeric values that we have here for x1 now, for x1. So we're doing a correlation of the numeric values. Of course, if you want to do this, you have to convert it first to a matrix of numbers. So the position of 24 is it's numeric, and yeah, I mean, and then you're looking at 30 to 32. Okay, absence, G1 and G2. Okay, so let's do this. That is the matrix, and then we're doing a correlation of the matrix. Okay, one of them is not numeric. Okay, let me just leave this one out of it. Let me leave this one out of it. Okay, so I just left okay, 31 to 32. So I left family relation out of it. Okay, in any case, there will be little or less correlation. So let's look at this. If you are able to interpret this, the meaning is that G1 is able, okay, G2 is able to explain 85% of G1. That is a very strong correlation there. And of course, it is vice versa for G1 being able to explain 85.21% of G2. So if we have this level of correlation and we keep both of them, it's going to be a clear case of multicollinearity. Okay, and this is a rule you must effect if you are when you are doing linear modeling. Okay, there must not be multicollinearity. Okay, so for that reason, we are going to drop one of them. We're going to drop one of them in our next iteration. Hopefully, that will be our last iteration for the particular, for the particular model. Okay, we're going to drop one of them. So we're going to be dropping, let's drop G1. All right. Let's drop G1. If we drop in G1, we're going to be having something like this for our model 5. All right, we're going to be having this for our model 5. So we have dropped G1 now. Let's see. I mean, if we drop G1, if G1 were to be that important, then our accuracy should drop significantly. But if we are still within the neighborhood of, 80 plus, that means we are good to go. So model 5, that is it. This is model 5. Okay, so the drop is very little. It was 83, 0.83 then. Now we are just at 0.82. All right. So let's look at it again. We left family relation. Now the reason why I decided to leave family relation is so that we don't have we don't just hinge it, since it has been significant up to this level, at least for this particular one, so that we don't just get left with absence and G2 absence and G2. Okay, that means the child's presence in class or not, and then the grades that the child has in their preceding is this semester now or 10. All right, remember that G2 here is also carrying in itself G1 because the two of them are highly correlated. If you drop the grade in G1, it's going to affect G3. All right, you don't need to be told that since they are both of them are correlated. Okay. Okay, so the summary gives us this. In the end, we have been able to get what I might call an optimal model. So how do you interpret this? All right, this is the intercept. This is the intercept of the model. Just a moment. Let's see. Do we have any question before we go to the final stage? If you have any questions, please drop it in the chat. you have any question, please drop it in the chat. Thank you. If you have any question, please drop it in the chat. Okay, so let's go ahead if there are no questions right now. Okay, so what we are going to do next, we have come up with the model. So we want to generate the coefficient of the model. All right, the coefficient of model 5 is this. So you use this coefficient thing. Okay, these are all the things about the model. What we need is a coefficient. All right, so if we run this and we run this, you get this. Okay, so you get this as your coefficient. Of course, it's coming like this for the family relations thing. So how do we manage this? Or maybe we should even remove the family relation in another iteration. Let's see what our let's see the result of our R squared. Let's do one more iteration. Okay, so let's remove this. I wanted to have it there before, but let's call this 6. Let's call this 6. Okay, 6. Let's see. Okay, I think we can let it go. We are still having 0.82. What is it there? Okay, we are good. Let's let that go. All right. So M6 understood OF. Okay, the coefficient of that. So you have model 6, and you have this coefficient of model 6. Good, and M6 coefficient. This all good. So you have this, and so what this simply means, let me just write it here quickly, is that your G3, which you are trying to model, in this case Y, is equal to, so this is the equation now, minus 1 point, which is the intercept, 6250, okay, plus 0.03610. Let's stop there. Absence. All right. Plus 1.10455. Let's leave it at that. G2. Okay. If I want to model, let's see, put the times here to avoid the error. Here also times. If I want to model my G3, this is the equation I need to model my G3. And we started with 33 different columns. In the end, this is all we need to model our G3. Okay? All right. So remember that the value of G3 in this particular data set that we have is the real value. Okay? So we will try now to use this model to generate a model derived G3. A model derived G3. A model derived G3. Hopefully, we'll be able to, hopefully we'll be able to see how that result comes. Okay? But in the meantime, do we have any questions? I would let's see if we have any questions. Please throw in your questions. I'll wait for the next 1 minute. Please throw in your questions. I'm waiting. throw in your question. Thank you. Somebody messaged. Okay, Robert T, you have a question? Take 1 minute. Please unmute yourself and ask your question, sir.
Yes, I just quickly want to apologize. First of all, I think it's my network or something that's been interrupting now. So I will catch up. I will try and catch up with those things I missed later. But on the ones I met, I want to ask: are the intercepts, are they predetermined?
No. The intercepts are not predetermined. The intercepts are generated by the model. So when you try to fit your model, when we did the simple one of yesterday, you saw when the line was fit on the data, that part where the line crosses the y-axis is your intercept. So it is the model that determines the intercept. Okay. Where so the intercept value is just a normal value when the value of your x is x1, x2, x3, when the value are 0. So what will be the default value of the of your dependent variable? That's the meaning of the intercept. So it is a model that generates.
Okay, it's dependent on the number of variables you create.
It is the model that generates the intercept. Let's just leave it at that. But the intercept is one of the results that must come out when you run your model. Okay. So yeah, yes, sir.
Thank you.
So any other? You're welcome. So any other question, please? I'm waiting if there are any more queries. Thank you. Okay, so if there are no more, Adeogun, please, yes, ask your question, please. Ask your questions. Thank you. Ask your questions now. You can unmute yourself and ask.
Can you hear me now? Can you hear me now?
Please.
Yeah. So I will have asked you to please come back on the aspect of this multicollinearity, the explanation where we eliminate G1, but I will try and look at that in the video when you drop the link. But should in case we eliminate G2, are we still going to have the same result as we're having now, or it's going to be different?
Yes, the two of them are collinear. The two of them explain each other. Okay, so it's just like they are twin. Why have the two of them there when we can remove one of them and still have the same result? That's the idea. That's the reason why multicollinearity is to be avoided. It's just like crowding the model with what is not needed. Okay, so that's the reason why multicollinearity is
Okay. Sorry, my second question is, like now that we're having in our first model, our R square is, I think, is 0.85, some stuff like that. But as we are now trying to track our model to have a best fit, so our R square is now dropping. Like now we're having 0.82. So is that when we say we have a very best model, or when we're having higher R square?
Okay, the idea is this. You want to have a model that is having 32 dependent variables compared to having 32 dependent variable with an R squared of 85, or a model that has 2 dependent variables with an R square of 82? That's the questions we are having now. So
Okay.
optimality also has to do with the simplicity of the model. Okay, there is no need of having a complex model when only 2 variables. Take note, only 2 variables are explaining 82%. You now bring 30 more variables because you want to explain just 2%, so that you can have 85. Or you're bringing 30 more variables so that you can have, so that the 30 more variables can explain 3%, when only 2 can explain 82%. So optimality of your model also has to do with the simplicity of the model. Does that make sense, sir? So now if you're talking, you need to unmute yourself. You muted and then you are raising your hand. So unmute yourself, please, and talk. So that is
Yes. And now I understand. Thank you.
all right. Thank you very much. So Mr. Arrow Training, Mr. Miss Arrow Training, unmute yourself, please. Quickly, because of our time. Arrow Training, unmute yourself, please. You are raising your hands and I'm calling you to unmute. Please speak.
Good evening, sir.
Good evening.
Sir. Sorry, the way we are selecting our variables, is it based on the correlation? Like, there are some positive correlations that have positive correlation, or we are just picking, trying to like iterate and get our final result,
Okay.
sir?
No. There was a significance measure we are looking at when
Yes, sir.
we print the summary. Let me go back there and show you.
Okay.
When we came up with the summary, there's significant values we are looking at. Look at this now. These significant codes. Look at what you have here, significant codes. The triple star, or the more the stars, the more significant the particular variable is. Okay? The more the stars, the more significant. Up
Okay.
to when there is no star at all,
Okay.
to see it, 3 stars, 2 stars. This is the meaning.
Okay.
Okay?
Thank you.
Good. So yeah, and so on and so forth. So this is these stars are encoded for the p value significance. Okay. So when you have it as 0, you have three stars. When you have it 0.001, you have 2 stars. 0.01 significance, you have this up to this. So this was what we used to pick our significant values. Okay. All right. So I hope that is okay. So what we are going to do now, let's see. We are going to use our model to carry out a prediction. Okay, so let's say model predicts. Model predicts. 1 minute. So predict model 6. So predict model 6 has given, so this is a vector of prediction. Of course, predict will predict our y-axis. It's predicting our G3. Okay, so if we want to print out what our predict is, let's just print out the first 20. 1 to 20. This is the first 1 to 20 values that is predicted. Okay. And then let's also, okay, I typed that. Let me type it here. M predict 1 to 20. And run that again. Gives us that. So let's see what our Y, which is the main Y, 1 to 20. It gives us this. So, okay. So we can begin to see the comparison. We can begin to see the comparison. 9.5, 10, 4.47 predicted. The main value here is showing 5. 9.56. The model is not doing bad. 10, 14.0, 14, 13.98, 14. Come on, 16.04. A model prediction. Original value is 16. 9.49. Original value is 11. That is a little bit lower than prediction. 13.91. Original value is 14. 11.7. Original value is 12. So our model has, I don't know, but I think our model has done very well. Our model has done very, very, very well. Okay, so I don't know, do we have any questions at this stage? So yeah, so this is where this is the end of modeling for this. So let's see if we have any questions. Do we have any questions? Did it make sense at all to you? Because at the end, you were able to see our predictions versus the result itself. Okay, the margin were very, very, of course, you saw that the R squared was 85. So whatever margin you were seeing, yeah, all of them, all our predictions had more than 82% accuracy. So even if the number is not exactly what you think, if you try to dig it out, you will see that it's more than 82%. Okay, it's more than 82%. Okay, so any questions, please? Any questions? So if there are no questions, I will make the data available to you, including the code. You can take out some time that will be left to you. Take out some time and run the code and using the data and see what comes out of it. If you have any questions or feedback, I'm always in the chat to help you out. So if there are no more questions, we'll end the recording. And so I'm going to be announcing cohort 3, hopefully this week. So kindly help us push it out to your friends and your contacts. In case you want to attend the cohort again, that's left to you. But so far, so good. But kindly help us push it to your contacts when we release the announcement for cohort 3. All right? Okay, somebody is asking a question there. What is the relationship between the M? So the M predicts, we used our model to predict for the value of G3. Yeah, we use our model to predict for the value of G3. So predicted value is what the model that we have built is able to predict. However, the Y itself is the original G3 in the data. So after predicting, that will predict for each of the corresponding values of G3 from beginning to the end of the data. That's what our model will predict. We are now comparing the first 20 elements. All right. So if I go back to the data, we are comparing the first 20 elements. The first one here, 5.21, predicted value. The real value is 6. Second predicted value is 4. The real is 6. So we can say it's getting better and better. Predicted value 7.57. The real value is 10. Next predicted value is 13.9. The real value is 15. Next is 10. Predicted is 9.56. The original is 10. Predicted is 15.3. Original is 15. Predicted is 11.6. Original is this. So it keeps going and going and going and going. Okay. So yes, that is what it is. I hope that makes sense. Okay. So if there are no more questions, I'll just wait for a few moments. If there are questions, please drop your questions.
Hello, sir. Sir. Hello, sir.
Yes, I can hear you, Papa T. Go ahead,
Yes,
sir.
I just quickly want to know if the part I said I missed when my network went off. Would I have a recap in the the video you recorded or it's not recorded
Yes,
yet?
the video is fully recorded. Even what we are saying now is being recorded. So
I will
you
be
can
able
go
to
to the
track it.
video. Yes, I'll push the video very soon. You can go to the video project and then you see it recorded here. Thank you, sir.
Thank you so much, sir. God bless you, sir.
All right. All right, everyone. Thank you very much indeed. I'll stop the recording now.